Hey, so I'm back again a little earlier than expected. Someone asked me a really good question, or a couple really good questions, honestly, on a video. Oh, it was the one about, it was titled something like No Seriously, Read Your Math Textbook. And they asked me a couple questions. The first part of which was how I would suggest going about reading a math textbook. And the second part was why I don't think the algorithmic approach to understanding things and always works. Really good questions. The second part is definitely a lot easier to answer than the first part. So rather than go through some really dry stuff on the screen and try and talk through it, I think I'll just give like a very generic, kind of all-encompassing kind of guidelines for what I would do. And the first would be to generally at the beginning of a section on a new topic, there's going to be a definition and or axioms and or theorems, whatever. Probably going to write those down. And if I need to translate those into my own words to make it stick better, for lack of a better word, then I'll do that. And I think that's also important, not only is to help remember this generally, but also so that you can use it to try and solve questions or problems that don't really closely mirror an example that it gives. So it might give you some examples, but the problem that you're working on, your homework or whatever, doesn't match one of those in format or whatever. You know what I mean? I think that's when definitions and theorems and stuff comes in, because those are going to be as general as possible. And I think that's one of the big reasons why people have such a problem with them, is they're so dang vague, is that people don't know, like, what is this? It's like, what am I supposed to do with this? This means nothing. And that's because it has to apply to everything within that topic, right? It has to be all encompassing. So it's good, and it's also bad for the same reason. So beyond that, if there's a proof for that definition or axiom or whatever, then I'm probably going to write it down, and I'm going to try and annotate, like, off to the side, the logical reasoning for transitioning and transforming one sentence into the next one, and how the following one came to be from the preceding one. And of course, all this is dependent upon being familiar with terms it uses. It's probably going to take terms from previous sections and or chapters, because all of this is foundational, right? And it's dependent upon being familiar with those terms and concepts, so that we can take those terms and concepts and put them together and create a bigger picture, is the whole goal here, right? So if we don't understand the terms that it's using, then we have to go back and reacquaint ourselves with these terms, so that we can come back and apply them to in a much more broad scope. Beyond that, if it gives examples that aren't especially clear to me, how the theorem or the topic applies to it, or how they got from one step to the next, or maybe they use some trick from some previous section, like a month ago, and you totally forgot about, I'll probably write that down too, just on the off chance that it comes up again, or a professor likes it. My professor in Calculus 3 likes to use all kinds of pain in the neck integration techniques when it's not necessary, when she just comes up with her own examples. She's like, oh, I can do this, so why not? So it's always good to keep the couple aces up your sleeve if you can. And I think those are basically the big issues. Is one, I'm looking at this theorem or this definition and I don't know what it means. If I don't know what it means, it probably means I'm not familiar with notation, how something is written, or terms that it references that were defined and talked about in previous sections. If I don't understand how to apply a theorem or a definition to a problem, then I probably didn't look at the examples closely enough, or I don't understand the theorem as well as I think I do. So those are the two things that usually get me. And I feel like if I can hash out and make concrete in my mind what the definition means and what it's saying and what it applies to and what it implies about other things, then I have a really broad scope to aim at a problem and understand it no matter what form it's in. And that's something I struggle with a lot, honestly, because right now I'm dealing with things where it's usually just integers, positive real numbers, And then sometimes it's like, oh, well, let's take this polynomial and apply the same things to it. Well, how are you going to do that? Because it's three numbers and it's variables with them, and one of them has an exponent. How are you supposed to treat that the same way as an integer? And it's like, well, if you're asking yourself that question, you probably don't understand the theorems and definitions as well as you do. But that's just me. That's where my hang up, oftentimes is. Hopefully that's helpful. And part 2 of their question, equally interesting, was why I don't think the algorithmic approach always works. And I guess I should have clarified a little bit. I think the algorithmic approach, and when I say that, I mean, like in my case, I have a topic, so I don't know why I'm speaking abstractly. I have a book full of them. When I talk about algorithmically, I mean, I have a definition for something, and then I have all of the steps to do something. So step 1, do this. Step 2, do this. If I can't do step 2, do this, and etc., etc., etc. And next to it, I have an example, and they're line for line apply to each other. Step 1, do this. Here's an example of that first step. Step 2, do this. Here's an example of how to do that, etc., etc., etc. So trying to make math as formulaic as possible. And for me, that's the pinnacle of my understanding, because it means ultimately that I know how to put something in my own words, and then I also know how to apply it to a problem. But being able to give yourself a step-by-step algorithmic process to solve something by means several things. One is that you know what you're talking about, you understand the topic already. And 2, it means in addition to that, you know how to put it in your own words. Being able to write something out step by step in your own words with an example next to it means you got it. You might not remember it tomorrow, but it means you got it in that moment. And now you can refer back to it whenever you like, and it's in your own words, and it's simply stated, and it should be pretty straightforward to you. Getting to that point is why I say, when in doubt, pull out a textbook and be comfortable with reading it and learning from it. But no, I don't think that's a bad way to learn. I mean, I rely on that very, very heavily, especially for test prep, is what I do. Lately, in the case of my 2 classes, I get practice exams. So I saw the practice exam, symbols and formulas and stuff, and then next to it I'm writing down what I'm doing. Multiply this by this, add this to this. Use these 2 things and create this one thing. For me, like I said, that's the pinnacle of my understanding, is that's the point I'm trying to get to, is to be able to understand something and then put it in my own words. So it's like a goal for me. And creating that is obviously a challenge, because that means I have to get over those first 2 roadblocks in order to get to it. You can't immediately do that. You can't not understand, partial derivatives and then immediately give yourself a step-by-step process for solving them. You can't work backwards. You have to understand something and then give yourself a step-by-step process to do it. So it's putting the cart before the horse. So hopefully that's clarifying. Thanks for the question. I appreciated it. It got me thinking, and I always appreciate things that get me thinking. Hopefully it was of some benefit to you, but thanks for watching, and we'll see you next time.